So what we'll try to do is let's try to see if we can pack in two things or just how many we can literally pack in to what we are trying to do today. So the first skill that we want to develop, we know that we have been doing statistics, right? We know that what is statistics. Statistics is the mathematical language to like put forward or capture beautifully the variation in data, right? So it all started with that french fries example, did it not? Like where I said that you could get 10 french fries or 8 french fries or 9 french fries and all of these things. So it's about statistics, we know, helps us capture. We have mathematical study of data and its variations. But now, what would we call the programming counterpart, guys? If, let's say, it's not necessarily a machine learning model that we are trying to develop, although we will have those sessions and it will obviously be of prime importance to all of us. And we will be, of course, taking it up very soon as we progress. Like we'll be writing codes for our models and everything. But then my question to you guys is, let's say just as general statistics, right? We are trying to find out the variation in data, study about the variation in data, make conclusions, make decisions. That's what we have been doing and knowing how it works, studying the math behind it. So that is the mathematical part or the raw statistics part that we have dealt with. But let's say what programming field would align most closely? So I want to gather data, I want to churn data, I want to, so not necessarily developing a machine learning models. So we wouldn't say not necessarily building a Keras model or building a PyTorch model or so on and so forth, right? Not necessarily, but it can be as simple as working with data, extracting insights from data, right? So that's the level 1 of programming where we want to be. So what I'm trying to convey via this is extracting data.
Sir, can you give me the meeting, the link to go to the Panini whiteboard because I joined late.
I have put it in the chat. My God, this is a different link. But anyway, try this. So acquiring, pre-processing, extracting insights, not necessarily always predictive from data. Guys, this is what we are actually trying to do if we have from a programming perspective. And for long and ever since the beginning of the class, when I say class, I mean the entire, let's say, whatever we have been studying. Since the very beginning, we have been focused on the mathematical side and the statistical side, and rightly so, because without those foundations, we are going nowhere. When we will very soon be solving problems from the previous years of AI Olympiad, those are going to be extremely crucial for us, right? So all these mathematical ideas. But now from a programming perspective, to keep a balance, from a programming perspective, it's about acquiring, pre-processing, right? And then extracting insights from data. Not necessarily are these insights always predictive, right? What do I mean by that, guys? That not necessarily these are always predictive. It's simple. What I mean is it's not that I'm always trying to predict something is happening or not, right? It's always like whether you'd be, you guys know certain themes. I know that you guys, although I haven't done them with you, I haven't done supervised learning and unsupervised learning. And there's a reason, because we haven't really started with machine learning or anything. We are making a extremely strong foundation. Let's say somebody, I saw one question in Q&A or something. Who was that? Is this fine? Are you seeing it now? Yeah, seeing it now? Karthik? That's because I was sharing a different screen. Guys, whoever this is, whatever rivals or anything, I would appreciate if you could do that in free time, or else it's just a little bit of spamming that happens, right? So I'll remove it. Anyway, so all these, if I'm trying to extract insights from certain data, it doesn't need to be always predictive. So as I was telling you, I know that we haven't talked about supervised learning, unsupervised learning. So the two worlds of clustering and classification we haven't talked about yet, like in complete detail. But then I do know that you guys have some concepts, and even in our introductory sessions, we had probably mentioned. So there could be so many different kinds of AI problems, right? And we have so many different examples all around us at this point. We know that it could be a self-driven car, right? It could be autonomously driven vehicles, as in, And then what AI problems would associate with autonomously driven vehicles, guys? Well, what would associate is, let's say, understanding all the objects that are in front of you. Object recognition is going to be a big part of let's say this entire exercise of self-driven vehicles, right? So why? Because while driving, since there's no human driver, you need to have a sense of all that is before you, right? And obviously advanced models of RCNN would be employed, because I need to know where a tree is, I need to know where another pedestrian is, or where an animal is, or what is in front of me quickly. The car should be equipped and completely endowed with this knowledge. So that's one kind of an AI problem, but there are plenty of AI problems, right? But we're going to tackle the most innocent ones. And there's a reason behind that, is because we have only done statistics. So what this field, and so it's not always predictive. It's not always that, well, what is the next show that Netflix is supposed to produce, and how will Netflix take this decision? Netflix will obviously go through its content reviews, content ratings, and obviously user profiles, right? And then they will try to cluster user profiles in a particular geographic region. You might have seen, we'll come to all of these examples in the future. You might have seen that while launching a new show, the show that's launched, a very few of them are launched entire worldwide, right? Which is good. But there are also regional content, and what gets launched where differs according to geography, right? In Netflix, what gets launched where, or in any streaming platform, and when I say what gets launched where, I'm definitely referring to geographical segregations. So guys, what program, it's beneficial to launch which program in which geographical area, this is a decision that's being taken by Netflix on the basis of why does it differ? What they're launching in one area, they're launching not probably later in another area. Why do you think, guys?
So maybe preferences of the people.
Exactly, preferences of the people, likings of the people, right? So a particular audience might be more suited in a particular month for a content that goes with the festival that's celebrated in that country, right? So more widely, more often than not, you would have a Christmas special in the entirety of Europe. You might as well in India as well. But I'm just saying the kinds of, again, let's say Nordic movies, or where you're like in the harsh travel modes and something, those might be there for Scandinavian countries as well. It depends a bit on culture. Of course, it could be given to the entire world as well, but it depends on the kind of viewers. What is the statistics of the viewers, right? What are their profiles? What are their ages? What do they enjoy watching? All of these things would be very largely factored in before Netflix takes on the recommendation, or not the recommendation that I was actually talking to, but which show to produce or launch next in which region, right? So that's a predictive problem once again. And some clustering might be done, that these regions are clustered in terms of similar preferences of content. So it could be classification, it could be, as in the self-driven vehicles example that I was telling you about, it could be clustering. There could be many of things that are going on, but it's not always these. Sometimes it's just the pure superset of many things that we do. And that superset is known as, very popular term in the industry. We have all heard of this at some point of time, right? It's known as data science. Now, what is data science? Well, exactly what we wrote above. A part of there is also data engineering, like acquiring and pre-processing, setting up production grade pipelines so that everything works for throughout the entire project and all of that. But I won't go into that. But acquiring data is a different problem. Acquiring data in our cases mostly would be solved by presence of public benchmark data sets, right? So that's there definitely. And it would depend on the kind of problem we are trying to solve. There might be a heavy bit of programming associated with acquiring the data. So let's say when I'm implementing a solution in the industry, or for, yes, particularly in the industry, do you think it would suffice to write a code that only works for me at my local? Does it suffice? Obviously not, right? So it should be equally usable by anybody and everybody in the team, or anybody and everybody in the organization. So there comes the whole concept of deploying, or whatever you have built, you deploy for others to sort of also participate in programming and all of those things. So that's why there's an entire architecture where when you're building a solution, there's an entire architecture. Where are you storing the data? Can you store it in the downloads folder of your computers? Well, in these kind of small projects that we do, of course you can, but think production grade projects where in the industry there are so many different things running, or for a data science company like Google, or they aren't data science companies, but their wings, for example, Google or Amazon or Microsoft, or how do these people deal with data, right? So they have their own storage services. Obviously, cloud plays an immensely important role. You can go and store your data. You can go and store your data in a S3 bucket in on AWS cloud, right? Or you can go and store your data in a DLS container, right, which is Azure Data Lake Storage. Why are these cloud storages of data enabled? So that obviously you don't want to have the overhead of keeping everything with yourself. Not only is that an overhead, that's also a handicap because others are not able to use it. You can configure role access on clouds on who has access to those buckets and who has access to those containers, and you keep the data there so that not only you, but if there's another programmer also in your team, he or she can come and read data from there and just basically do their stuff as well, right? So a lot of things come when it's programming for artificial intelligence or programming for data science. Today we are talking about data science since our roots have been statistics. So it's about trying to extract information, trying to extract insights. And there are a lot of tools that help us with this, right? So we've got, but the ones that we will start on with today, since it's the first time ever we are doing this, we'll primarily focus on Python and pandas. As the days progress, whenever again we go to hands-on sessions, we will focus on visualization with Matplotlib and Seaborn. And guys, when we do these things, right, you will truly understand. Today's example, I don't know if we'll have time for two, but today's example won't just necessarily be an out and out statistics example. It will be a programming example for today. And then next week, to close the hands-on session, we can do a statistical example. And then we'll gradually move on to more complicated stuff beyond the level of statistics that we have been doing, even more complicated stuff, right? So why is programming so important? Why must programming go hand in hand with all of the statistical mathematics or all the deep statistics that we are learning? Why do we also need to be able to code, guys? What do you think? Why is coding important when it comes to like what we are learning? Because you might have seen, yes, Yuvan.
So only learning the math point won't help us in making the actual models. So programming is like an interface where we can actually make the AI models.
Exactly. That is one part. But even if we don't talk about AI models, and let's say even for something like, do you think statistics widely, how do you think the real life problems in statistics are solved, right? Yes, models are made and all of that. But think of, you have actual data and you want to do something as simple as plotting a histogram, as we have been seeing, right? Or you want to find out what differs, how a particular parameter, as simple as that, just trace out a graph, right? How one parameter differs with respect to another. So all these with bulk of data, huge volumes of data, then it would be difficult to just do it on hand with statistics, right? You need a programming language. When the size of data is going to grow, to be able to apply the statistical principles that you learn, to be able to question the data, to be able to query the data, to be able to gain insights from that data, it is very important to have the data in as data structures, literally, right? So that's the algorithmic side of it. And then depending on what kind your data is, you choose a suitable data structure that holds your data the best. And then you build programs. So it's also about scale. One word I was looking for is scale, right? Scaling your statistical ideas, scaling your statistical applications. For example, you want to build something that automates, that takes in various scenarios, generates an histogram, right? Conforms to a particular distribution and tells you which one is the best fit. So of course, these are real life problems that statisticians are solving every day. But how are statisticians solving it? Sitting and doing those, solving the binomial theorem equation, not binomial theorem equation, but the binomial distribution equation 1,000 times. Are they really working out? Because real life values, when you're working with real life data, right? For example, statisticians of the Indian government, what are they doing? Are they simply doing, and are they simply sitting and actually solving the equations on pen and paper? No, the equations are being solved, but on computers, right? Because we have the capability to write codes which will find out because real life values, real life distributions will be skewed. Real life values will be immensely large. They will be enormous, right? The pool of values that we'll be working with are going to be really, really large. So to be able to apply this, right? Again, when the football match is done and the statistics is there shown in front of you, right? Like how many passes, what was the possession of each team, right? How many shots on target, what was the score, right? How many fouls, all of those things that you have. How is that being computed? Is someone literally, was someone counting throughout the day? No, there's a computer in place which has access to the data store, and then it just has a program to acquire it, clean it, extract insights from it, and then also telecast it or broadcast it to the users in an aesthetically pleasing way or in an appealing way, right? So it's all computers. When it comes to statistics being propagated or being applied in daily life at scale, solving actual problems with statistics, you need to be able to know a little bit of programming, right? It could be Python,